All right, so I got cut off. So imagine that you're presenting vignettes to your participants, and the vignettes are talking about being approached by a couple, and either the couple's heterosexual or they're homosexual males, and you're asking the participant how likely would they be to offer help. So you have two independent variables that you're looking at, although one is a participant variable because you are not manipulating it, and that would be the gender of the participant. But the point is you have two variables that you can look at in relation to your dependent variable, which is likelihood of helping. So let's say we get, for homosexual couples, the females are more likely to help whether or not the vignette entails the requester being homosexual or heterosexual. But then you see an effect for males where they're only likely to help more in a heterosexual vignette than when it's a homosexual vignette. So this would be, hopefully you've identified it, an interaction once again. The lines are not parallel, and you're seeing an effect, a change between homosexual and heterosexual helping for males only. You're not seeing that change for women. So when you increase the complexity by adding more levels of the independent variable, it can definitely become more difficult to discern what is actually happening with the data and what it means. So this is an example where we're asking how anxiety influences people's performance on a task, where the task can be easy and hard, and we manipulated anxiety to be low, moderate, or high. So you're more likely to use a line graph once you start splitting up a variable into a low, medium, high type definition. And though this example looks nice because it has that nice interaction effect, the data usually doesn't come out this nicely. Usually you can get weird curvilinear effects. So imagine maybe this dot being up here and then coming back down. So sometimes it becomes harder to interpret. So you have to keep that in mind when you're adding more levels, how it might make it more difficult to interpret the data because it never comes out as cleanly as you'd like. In another example, we could be looking at gender and the class size and the type of instruction method, how this will influence test performance. This is how you can put it in a table to simplify what the data looks like. So here's class size at the top. Then you split it by gender underneath it. And then you have a column representing the third variable. So in this cell, I'm looking at males in a class size of 10 under lecture. This would be males in a class size of 10 for discussion, males in a class size of 40 under lecture, males in a class size of 40 under discussion, and then here it's repeated with females. When you're drawing the tables, however, you have to actually separate it by one level of the independent variable. So at least one of the independent variable has to be separated into two graphs. So here would be my males, and here would be the females. So you can't actually easily show this in one graph. You would have to separate it. So you would show one graph representing males and showing the relationship between class size and lecture. And then the next graph you would show with females showing the relationship between class size and lecture. Now, because this is a 2 by 2 by 2 design, one of the main reasons you would do this is if you actually got what I talked about before, that three-way interaction. So the three-way interaction is basically saying one of these graphs you're seeing one type of effect and then you're not seeing the same pattern in the next graph. So you usually have to tinker around to figure out what independent variable you want to split up to figure out how are you going to show that significant interaction. If you don't have a three-way interaction, you only have significant two-way interactions, then you're going to collapse across that third variable that isn't important. So remember, with the 2 by 2 by 2, you have more effects you have to look for. You would have three main effects. You would have three two-way interactions, and then you would have that one three-way interaction. This is why you want to be very careful when you're adding levels. You don't want to get too many levels, and you don't want to get too many independent variables. Even if you kept it at 2 levels, You're expanding the number of conditions you need and the number of people you need if it's between subjects. So with 3 independent variables at 2 levels apiece, I would need 8 groups. I'd probably want at least 20 people, usually 30, but at least 20 per group. So that's 80 people. I'm sorry, 160 people. That's more than that. And then if I had 4 independent variables, that would actually come out to 16 groups, assuming it's all between subjects. And once again, for each group, you want at least 20 people. So that would be 320 people that you would need. So the number of people balloons as you start adding independent variables, which is why you want to be careful. So that's the end of this lecture. Have a great day.